Recently, you might have noticed a satellite train running in the sky. This fantastical train, designed with the purpose of telecommunication, is owned by SpaceX. SpaceX is planning to launch 12,000 satellites in the coming decade, with a potential future extension to 42,000. This is being done with the aim to provide widely accessible broadband networks that perform with high quality and low latency. In order to achieve this, they need to launch a large number of satellites into orbit. SpaceX relies on rocket reusability as the key breakthrough to reduce the cost of access to space. To realize their goal, they first invented a two-stage rocket named Falcon with auto-landing capabilities. After this, their low Earth orbit satellites, working as relay routers, are re-engineered to maintain stability in orbit. Finally, the satellites are connected through laser beams. Much like our fiber optic cables on Earth, light pulses will be used to transmit information between satellites. Similarly, Bitoss Global has a vision to offer enterprise-level end-to-end connectivity in over 5,000 cities around the world. In order to have the access router reach a number of 15,000 units, we need to radically rethink and innovatively design the telecom infrastructure. A number of steps have been taken to keep the service very affordable for all business users. We carefully re-engineer the routing engine running on the cloud network, effectively automate the cloud router launch, intelligently calculate the instant path, and efficiently build the global backbone, exclusively with the latest SDN technology. This is our network topology. Right off the bat, you'll notice that all the sites are on the cloud. The entire network is completely virtual, a feature that's rare even in other SD-WAN providers. The connection points are virtual machines, or VMs, instead of physical ports or racks at data centers. This allows us to easily place points of connection around the world, virtually anywhere that has a cloud presence, making previously remote areas easily accessible. VMs have been set up and connected around the world. We have mesh networks in the EU and US, and in APAC, all seamlessly connected virtually through VMs on different cloud providers. With our SD-WAN technology, we can very easily and very quickly set up these connections. What once could have taken up to 30 days can now be achieved in a mere half hour. There are several advantages associated with using VMs as PE routers. One of the main advantages comes in the form of easy customization. This is what allows us to create self-serving PEs that perform on demand. We're able to create connections with excellent bandwidth as we're utilizing the local internet peering of the OTT player, which in Singapore or Hong Kong would be AWS, or Google in Taiwan, the US, or EDU. Utilizing the cloud also allows us to easily take advantage of their excellent security policies. This ensures that the consumer's connection remains completely secure, and each link that's created is bilateral. Our SD-WAN network allows for link diversity, allowing for both public internet connections or private DCI connections as well. Here we have an example structure of the VM connected on our network. It is first converted into a PE. Users can connect through the internet via 5G, 4G, or DSL, and it is then connected to the PE through the access interface, which is in turn connected to an access port. The PEs are connected to each other through a backbone link that is attached through the corresponding interface and backbone port. All of these PEs together create our SD-WAN network with an SLA guarantee. In summary, our unique take on SD-WAN allows us to create wide area networks over several regions seamlessly and efficiently. It is very easy to set up and cost effective.